This video we're going to talk about complex numbers. A complex number z can be written as a plus bi, where a is the real part and the bi becomes the imaginary part. To talk about these, we need to make sure you remember what an imaginary number is. You've probably seen this before. You've came to my class. So the imaginary unit is I, and that is representing the square root of -1. So if I have I squared, that means I have the square root of -1 squared, which becomes -1. We will use this fact a lot when we're multiplying and simplifying so that we can rewrite our imaginary numbers as accurately as possible. So first thing we're going to do is look at some properties that deal with those imaginary units so you can recall how to work with them. So let's say that we had an example here of the square root of -25. Well, if you remember your square root rules here, we can split this up as -1 times 25 and rewrite this as the square root of -1 times the square root of 25. Now this makes our work a lot easier because we know the square root of 25 is 5 and the square root of -1 is I. So the answer for this would be 5i. Notice that I wrote the number before the imaginary I right here, just like it is in our complex numbers. Let's try another one of those just in case. So we have a negative on the outside and a negative on the inside. We're just going to carry that outside negative with us. Do the same math by taking the -1 off the 169 from the inside. Oops, I lost my negative. Don't lose your negative. Square root, negative square root of -1 times the square root of 169. So the square root of 169 is 13. And if you don't remember that, just draw yourself a picture. A square can be made out of 13 and 13 on the side to give us 169 points. Ooh, I lost my negative again. -13, because this negative here. And then the square root of -1 is I. So this is -13i. Another example of this can be used when you have the square root of a fraction. So the square root of -8 over 49. That negative on the outside is going to do the same effect that it has been. We're going to pull out a -1. And then we can leave 8 over 49 together. But I don't like that it's a fraction, right? So I can split this -1 off into its own square root, and I can split each one of the fractions into its own square root. So hopefully I can get a perfect square from this 49, because if not, then I have to use conjugates to get the square root off the bottom, because we can't have a square root on the bottom. But fortunately, 7 times 7 is 49. And I keep my I, and you can leave your I out in the back or in with a problem, it doesn't matter. And then now we have to do the square root of 8. So we need to think about what times what gives me 8. That's 4 times 2. And then 4 can be split into 2 times 2. So the square root of 8 is really 2 square roots and then a 2 on the left inside. So this can be written like this, or you can do 2i the square root of 2 over 7. Either one of these notations are correct. Okay, so let's get into it. Let's look at some operations that we can work with complex numbers. The first operation is addition. So let's say we had two complex numbers, 3 plus 4i. Notice that I is always the last thing that I write when I'm writing a complex number. So you always rearrange it so that the real part comes first and the imaginary part comes second. Essentially what we're going to do here is, if there's a plus sign in between our two complex numbers, is we're going to combine like terms. So I can drop my parentheses if I don't have anything to distribute. So here I could drop my parentheses Or I can think about this as the associative property. We're going to regroup our real parts. So 3 minus 5 and regroup our imaginary part. Now you can skip these steps and just add 3 minus 5 and 4 plus 7. But I wanted you to see what's happening here. So this becomes negative 2 plus 11i. And then you're finished. You don't have to give me a number. You don't have to keep working. It seems a little too easy, but that's all I want you to do. Combine the real parts, combine the imaginary parts. But be careful, sometimes I can throw in a little trick. So what if I did negative 5 plus 8i minus 2 minus 12i? This gets a lot of people. Don't let me get you with it. This minus is really a multiplication of negative 1. So before I can drop my parentheses, I need to distribute that negative 1. But I don't have a negative 1 in front of this first parentheses, so I can drop those parentheses. And then multiply out negative 1 times 2 is negative 2. And don't forget to multiply out by the imaginary part. Negative 1 times a negative 12 is a positive 12, just like when we're distributing. Okay, so that gives me like terms are my real parts, so negative 7. And then my imaginary part will give me 20i. So negative 7 plus 20i. Okay, I could also give you that in a long row. I could have put a whole bunch of stuff together. They don't have to be in two separate complex numbers. They can be multiple complex numbers, and you're just combining like terms. Another thing that we can do is the operation of multiplication. So let's start off with an easy one here. We have I times 5i times 7i. Okay? So you're going to multiply the numbers and combine the i's using exponent rules. So it's I times I times I. There are 3 i's. And then 35 is 5 times 7. Now, we can simplify this more because we know that I squared is a negative 1. So I split this 3 i's into 2 i's and 1 i because 1 plus 2 is 3, exponent rules. And I squared is negative 1. So this is negative 35i. Notice that it's only the imaginary part. That's okay. It happens sometimes. But anytime you come up with an I squared, you want to change it out for a negative 1. So just be careful. That happens a lot in multiplication. Let's try a couple more multiplication problems. This time we're going to have real and imaginary parts. Not sure how you learned how to multiply a binomial in school. You might have used the FOIL method or the box method. I'm going to use the FOIL method to multiply. Now notice I do have two complex numbers, and this time they do not have an operation in the middle. So it's assumed that that operation is multiplication. Okay, so we're going to multiply the first two numbers together. 3 times 5 is 6. We're going to multiply the outer numbers, so 3 times 7i is positive 21i. Now we're going to do the inside numbers, so 4i times 2 is 8i. And then the last numbers, 4i times 7i. And be careful here, that's 28i squared. But we don't write it as I squared. So I'm going to cross this out and replace it because I squared is negative 1. This is negative 28. Now do not give me an answer with I squared in it because I will mark it wrong. Change your I squared to a negative 1. And now we can combine like terms. Negative 28 plus 6. Okay, so where was I at? 6 minus 28 is negative 22. And then we'll combine the i's. 21 plus 8 is positive 29i. And then you can stop. That's your answer. We have a real part and imaginary part with no I squares. Looks fantastic. I'm going to do another one of those. If you don't need it, you can fast forward and move on to division. if you think you know what you're doing, try to give it a try and see if you get the same answer as me. Okay, again, there's no operation in the middle. Always check for an operation. This one is going to be multiplication. I could do I'll do FOIL again. Oh, I apologize. 5 times 1 is 5. Outside would be 5 times 3i to give us plus 15i. Negative 7i times 1 is negative 7i. And then negative 7i times 3 is negative 21i squared. We don't want to leave that I squared there, and it's already negative, so it's going to become plus 21. So that I changes our original negative sign and makes it plus 21. Now I can combine like terms. You should always be combining your first term with your last term and your two middle terms together if you're using FOIL, because this will always be an I squared. It'll always change signs. So that's 26. And then 15 minus 7 is 8i. So that's 26 plus 8i. Don't make it more complicated than that. Always check your signs. The last thing we need to cover today is division. And there's something we need to talk about. It's called a complex conjugate. So a plus bi has a conjugate of a minus bi. When I multiply them together, the middle terms cancel out, leaving me with perfect squares that can be in the denominator of a fraction. But right now, an I can't be in the denominator because it's the square root of negative 1. So if I have a case, like let's say we have 10 over 7i, this is not a good form of the answer. We have to get this I off the bottom. Now, this number doesn't look like a complex number, right? The real part is 0, so it's 0 plus 7i. So the complex conjugate, you just change the sign in the middle, is 0 minus 7i. So I'm going to multiply the numerator and the denominator by negative 7i so that I can remove that square root from the bottom. Okay, so in the numerator, we're going to do 10 times negative 7, which is negative 70i. And the denominator, that becomes negative 49, and then I squared. So here's where it happens. I squared, we're going to cross it out again. And instead of negative 49 I squared, this is positive 49. So now the denominator is imaginary free. There's no square roots on the bottom. And then just rewrite the numerator, negative 70i, and then here is your answer. Now you can reduce that by dividing by a 7, but I'm just going to leave it right there, negative 70i over 49. So let's do another one. Let's say this time I had a whole complex number on the bottom, so you can see this example. In the numerator, I only have a constant, so when I multiply by the conjugate, I'm basically distributing that constant on the top to give us 6 minus 3i, and then in the denominator, and this will happen every time, you're going to FOIL. So square this one, 2 times 2 is 4, and then this middle term becomes plus 2i minus 2i, and I think I did that in the wrong order. I'm sorry if I distracted you. And then a negative 1 times a positive 1 is a negative I squared, which becomes plus 1. And so right here on the denominator, we're doing the same math we did when we FOILed. We're going to combine like terms now. So that's 5, because 4 plus 1 is 5. And then the imaginary part cancels itself out. And that's the point of multiplying by the conjugate. Okay, and the numerator is 6 minus 3i. Now this is a fine answer. I will accept this answer. This is perfect. You can leave it like that, box it, and be done. You can also write it by splitting the fractions. That's also the correct answer. And this, a lot of professors like to see it like this because this is written like a complex number with our real and our imaginary part. But I will accept either one. Okay, if you have any questions, feel free to reach out to me. You should be able to do all of homework 5. Make sure your test gets turned in on time, and you complete homework 5 for this week.